Hello everyone. In this video I am going to explain about the gaseous laws. We have total 4 gaseous laws. These gaseous laws are proposed to study about the behavior of gases. Total we have 4 gaseous laws: Boyle's law, Charles' law, Gay-Lussac law and Avogadro's law. Total 4 laws are there. These 4 laws can say about the behavior of gases. Among that 4, I am going to explain in this video about Boyle's law. Boyle's law, also known as Marioth's law. Okay. So in Boyle's law, Robert Boyle, who gave this law? Robert Boyle. Robert Boyle studied the effect of pressure on the volume of the gas. Okay, how the volume of the gas varies with the effect of pressure on increasing the pressure or on decreasing the pressure, how the volume of the gas changing, he studied about. Okay, so according to Boyle's law, at constant temperature, by keeping the temperature constant, the volume of the given amount of gas, is inversely proportional to pressure, pressure applied. Okay, so what Robert Boyle's law says here, at constant temperature, by keeping the temperature constant, the volume of the given amount of gas, is inversely proportional to the pressure applied on the gas. Okay, that means here volume is inversely proportional to the pressure applied. So what are the constant terms here? At constant temperature, and at constant number of moles. These two should be fixed. Temperature and number of moles should be fixed. At that condition, the volume of the gas inversely proportional to the pressure applied. Okay, so here inversely proportional means if the pressure increases, the volume decreases. If pressure increases, the volume decreases. If pressure decreases, the volume increases. So here V equal to some constant K by P. So PV equal to constant K. Okay, so the product of pressure and volume always constant. At what condition? At a constant temperature and number of moles. At constant temperature and number of moles, always the product of pressure and the volume of the gas always constant. PV equal to constant. Okay, so suppose I am taking one gas, that gas having P1 pressure and the volume of that gas is V1. So what I am doing here, I am changing the pressure of the gas to the P2, and definitely the volume of the gas also changes to V2. Okay, so the product of these two is equal to the product of these two. So P1 V1 is equal to P2 V2. At what condition? At constant temperature and number of moles. See, but for better understanding, from this relation, if the pressure doubles, the volume of the gas decreases to 2 times. Means if pressure doubles, then the volume become half. If pressure increases 4 times, the volume decreases 4 times. If pressure decreases 2 times, the volume increases 2 times. Okay, inversely proportional. For example, for better understanding, I am giving here, suppose here it is P pressure of gas, volume, and the product of pressure and volume. Suppose I am taking here 10 atmosphere pressure, and the volume I am taking 2 liters. What is the product of these two? 20. The product of these two, 20. Suppose here I am reducing the pressure to the half, means 2 times I am reducing, right? Okay. And what happens? The volume increases 2 times, means the volume becomes 4 liters. So 5 into 4 again 20. Same thing here. Again I am reducing the pressure to the half, 2.5 atmospheres. Again this volume becomes 8 liters, because I am reducing the pressure 2 times, then the volume increases 2 times. 2.5 into 8 again 20. So the product of pressure and volume always constant. At what condition? At constant temperature and number of moles. Okay. So PV equal to constant. So if you apply log to that, log P plus log V is equal to constant. Log P plus log V equal to constant. Okay. Here how the graphs are plotted between volume versus pressure at constant temperature. Okay. So the graphs drawn at a constant temperature are called as isotherms. What we call? Isotherms. Iso means constant or same. Graphs on Boyle's law. Okay. These graphs are plotted at what condition? Plotted between pressure versus volume, right? At constant temperature. Okay. So the graphs plotted at constant temperature are called as isotherms. Okay. Iso means same, therms means term that indicates temperature. Okay. At constant temperature, no, we are drawing the graphs at a constant temperature. So these are all called as isotherms. Okay. How the isotherms are? Here I am taking on x axis I am taking volume, on y axis I am taking pressure. Okay. So what is the relation here? On increasing the pressure the volume decreases, on decreasing the pressure the volume increases. Okay. The graphs are like this. Okay. At what condition? At a different temperature. For example, this plot drawn at a T1 temperature, and this drawn at a T2 temperature, and this plotted at a T3 temperature. Okay. So sometimes in question they may ask what is the relation here, T1, T2 and T3. Okay. So to do this easily, see here I am taking one particular point here to here. Okay. So the volume at T3 temperature this much, and the volume at T2 temperature this much, and the volume at T1 temperature this much. Okay. So generally on increasing the temperature the volume also increases. Okay. Now on increasing the temperature the volume also increases. So here where the highest volume at what temperature? T1 temperature. Okay. Now so here T1 is greater than T2 is greater than T3. Okay. So many times repeated these type of questions from Boyle's law. Okay. What is the relation here? What is the order of temperature in these plots? T1, T2 and T3. Okay. This is one graph, and another graph, let us see second graph. P versus 1 by V, pressure of gas and inverse of volume. Okay. So what is the relation here? Directly proportional. Okay. Volume is directly proportional to 1 by P, or you can say here pressure directly proportional to 1 by V, directly proportional. So it increases. If pressure increases, the 1 by V value also increases. Right. Next, the relation between volume and 1 by P, same volume 1 by P, okay, increasing. Next graph, see here I am taking log P, on x axis I am taking log V, okay. So the graph plotted between log P and log V is like this, means what, here you can see log P plus log V is equal to constant, okay. So to make it constant, if it increases, if log P increases, log V must be decreases, because log P plus log V is equal to constant, no. So it should be constant always, okay. If it increases, this must be decreases to make it constant, okay. So that is what I have shown here, log P plus log V equal to constant, right, constant, okay. So on increasing the log P, the log V decreases, on decreasing the log V increases, okay, right. And one more important graph here in Boyle's law, PV is always constant, even if you increase the pressure or decrease the pressure, this never change at constant temperature, right. At constant temperature, the product of pressure and volume never change, even if you increase the pressure or volume. On increasing the volume or decreasing the volume, on increasing the pressure or decreasing the pressure, this product never change. So it is always constant. The graph should be like this, okay. So these are the important graphs, isotherms of Boyle's law, okay. And let us do some numerical questions on Boyle's law, how they will ask, okay. Okay, see here there is a numerical question on Boyle's law. If 200 ml of gas, 200 ml means 2 liters, if 200 ml of gas compressed by increasing its pressure by 20%, the pressure increased, 20% increased, then calculate the final volume, okay. So what is the initial volume of the gas? Initial volume V1, just assume V1, that is 200 ml. 200 ml. What is the initial pressure? We don't know. Here in question they did not mention the initial pressure, you just assume it is P, okay. And here in this question they are asking final volume V2 how much, but P2 is increased by 20%. Increased by 20% means 20% of its initial pressure P and 20% increase, 20 into P by 100. So P2 how much? P plus 0.2 P, final pressure is 1.2 P, initial pressure P and final pressure 1.2 P, okay. Now substitute here, we know the relation P1 V1 equal to P2 V2. What is P1? P. What is V1? 2000. What is P2 here? 1.2 P into what is the V2 final volume? V2, okay. So here this P and this P get cancelled, 2000 by 1.2 is equal to final volume, okay. So on simplification of this one, you will get how much? 1666.6 ml equal to V2, okay. So what did you notice here? The initial volume 2000 ml means 2 liters, but the final volume is 1666.6 ml only. Means what happens here? By increasing the pressure by 20%, some volume reduced, okay, right. Let us do one more problem here, okay. We have one more question here, a very simple question. Calculate the volume of balloon if its initial volume 4 liters at sea level. sea level means what? At normal conditions, the pressure always at sea level, how much? 1 atmosphere. If they mentioned it to sea level, then we have to take the atmosphere 1 atmosphere. Okay. So calculate the volume of balloon if its initial volume 4 liters at sea level and it is taken to the top of mountain. It is taken to the top of mountain, moving up. Okay. We know that at higher altitudes the pressure decreases, no? The pressure decreases when compared to the sea level. Okay. At sea level, how much the pressure maintaining? 1 atmosphere, but the balloon is taken to the top of the mountain where the pressure reduced to 0.75 atmospheres. 0.75 atmosphere. So we have to calculate the volume of the balloon at a constant temperature. You just assume at the sea level and at higher altitudes also the temperature is constant. So if the balloon is this much at the sea level, okay, if it moves to higher altitude, definitely it increases the volume. Okay, na? Right? Here, what is the pressure P1 at sea level? 1 atmosphere, and the volume of balloon how much? V1, that is 4 liters. Okay, here it is 4 liters this balloon. Okay. P2, the pressure reduced to what? 0.75 atmospheres. We need to find here what is the volume at a higher altitude, that is at top of the mountain. Okay. So P1 V1 equal to P2 V2. P1 1 atmosphere, V1 4 liters, and P2 pressure reduced to 0.75. What is the volume? 4 by 0.75 equal to V2. Okay. So on simplification, you will get this value V2 equal to 5.33 liters. Okay. The initial volume 4 liters. When it moved to the mountain, definitely the pressure reduces, then the volume increases, the volume of the balloon increases. How much volume? It is increased to 5.33 liters. Is that clear? Alright. So these are the some model questions on Boyle's law. Thanks for watching.